So, hello everyone, welcome back to our Python programming full course for beginner. I hope all of you are doing great and are practicing the concept which we learned in the previous lectures. If you are joining this course like for the very first time, I highly recommend you all for watching the previous lecture in order because every new topic builds on the concept we have already covered. In our last lecture, we learned how to write our very first Python program using the print function. We also explored the difference between interactive mode and script mode, learned how to save Python file, and understood when to use each mode. Today, we are going to move one step deeper into the Python language before we start creating variables, taking user input, or writing complex program. It's important to understand the building blocks because that's how you will understand the fundamentals. Like, think of it like learning English. Before writing sentences, you need to first learn the alphabets, then you need to learn the word, then you need to understand the meaning, and finally the grammar. So programming works exactly in similar way. In today's lecture, we will begin by understanding the Python character set, the collection of characters that Python recognizes. After that, we will learn about the tokens, which are the smallest building blocks or the lexical unit, and we will also explore keywords and which so keywords are basically the reserved words and with special meaning in Python, and identifiers also, which are the names we give to variable, function, or any object or any class to refer to an instance. So we will not only discuss these concepts theoretically, but we will also perform live coding throughout this session. So I'll intentionally make some common mistake that beginner often makes so you can see the error Python produces, and more importantly, you understand how to fix them. So by the end of the lecture, you will know how Python reads your code and what names you can and cannot use, and you will have a much stronger foundation for the upcoming topics like variables, data types, and user input. So let's get started. So, before we learn something new, let's spend a few minutes revising what we have already covered. So, revision is one of the best way to strengthen your programming skills because programming is not about memorizing, it's about understanding and practicing. So, let's start with a very simple question, which was what is a program? So, what do we understand? A program is simply a set of instructions given to a computer to perform a specific task, just like you follow a recipe to cook food, or a computer similarly follows instruction written by a programmer. Now comes the question, what is a programming language? Computer understand only machine language, which is made up of zeros and ones, known as binary. So writing program directly in machine language is extremely difficult. So we use programming languages like Python, C++, Java, Ruby, and other. So these languages allow us to write instructions in a way that is easier for human to understand. The Python interpreter then translates those instructions to the computer and the computer executes them. So next, why did we choose Python? Python is one of the most beginner friendly programming language, and it have very simple and easy syntax to read, and it is widely used in web development, automation, data analysis, AI, machine learning, cybersecurity, and any other field. You just take the name. Because of its simplicity and what do we say versatile nature, Python is often the first programming language people learn. So after that, we learned how to install Python and verify that it was installed successfully. We also saw that Python provides an application called IDLE, which is useful for beginners to write and run Python programs. Then we explored two ways of writing Python code. The first is interactive mode, and the REPL mode, also known as. Uh, in script mode, we write our code in a file with a .py extension, save it, and then run the entire program. This is the method used to build real-world application because it allows us to organize and reuse our code. And in interactive mode, we write one line of code, press enter, and Python executes it immediately. So this is perfect for quick experiments, testing small pieces of code, or learning new concepts. The second, uh, we learn our very first Python function, the print function. The purpose of the print function is to display output on the screen. For example, if we need to write something, we want to display something, we will write print, parenthesis, then quotation marks, and whatever string, whatever message you want to display on the screen, you pass there. So this tells Python to display the text on the screen, whatever you pass. We also explore different ways of using print. We printed text, numbers, multiple values, and special characters. By now, you should be comfortable writing print statements. So everything we have learned so far forms the foundation of Python programming. Now it's time to answer an interesting question. When we write something like print hello, how does Python know that print is a function and how does it understand the quotation mark, the brackets, and every symbol we type? The answer begins with something called the Python character set, which is exactly what we are going to explore next. Let's dive into it. As you can also see, alphabets of programming language. What are character sets? Now that we have revised the basics, let's understand the very first building block of every Python program, the Python character set. So what exactly is a character set? You can see the definition. A character set is a collection of all the valid characters that Python recognizes while reading and executing a program. In simple words, every symbol, letter, number, or any special sign that you or I type in our Python environment or in our Python code comes from this character set. Think of it this way, like when you are learning English, you first learn the alphabet A, B, C, D, and so on. And then you use those letters to form words, sentences, and eventually we start creating uh, stories we develop. We are able to speak fluently then. Programming works in almost similar way. Like before Python can understand variables, function, loop, or classes, it first has to recognize the individual characters we have typed or we instructed. So without characters, you can't write a single line of Python code. So for example, let's say if I want to write, okay, now my idle shell should be visible to you all. So let's say if I write this name is equals to Rishabh, then although it looks like a single statement, but Python actually sees many different characters. It sees N, it sees A, it sees M, E, then a white space, then an equal to character, then or an assignment character, assignment operator, then a white space, then quotes, then R, then I, S, H, A, V, H, then another code. It sees the letter N, A, M, and E. It sees a space. It sees a assignment operator. So finally, it sees the letter inside the string. Every one of these is a valid character that Python understands. So if I'll call this, you can see it is giving me the value stored in the variable name. So let's say if I want to print a 10 plus 20, I'll write print 10 plus 20. The output we know it will be 30, but here Python recognizes the letter P, R, I, N, T. It recognizes the opening and closing parentheses. It recognizes the number 1, 0, then 2, 0. It also recognizes the plus symbol, which is the addition operator. So every single symbol has a meaning here. Nothing in a Python program is ignored unless it's specifically allowed, such as certain white space or comments. Now let's see what kind of character Python allows. You can already see it on your screen. The letters, the digits. So the very first category I'll cover is letters. So Python accepts both uppercase letter from A to Z and lowercase letters from A to Z. For example, name I have written Rishabh, and if I want to create a variable named city where I want to store New Delhi, I can do that also. So I'll create a variable city and I'll put value New Delhi in it. And if I'll call it, here you can see it is giving exactly same output which we want. So one important thing to remember is that Python is case sensitive. If I'll write name, so as as here you can see, if I will write name, right now it's Rishabh. If I write Rishabh Kumar and I change the name first alphabet to caps, then name. Now what I'm calling a variable name which is all caps, N capital, A capital, M capital, E capital. The error which is being thrown here is a name error. What does it say? It says name NAME all caps is not defined. Did you mean name? So it is suggesting me that it might be name. So if I try to call this, it will give me this variable, the value stored in this variable. And if I'll call all small name, it will give me this variable. Now, as the name of the variable is name itself, it might sound confusing. So for common understanding or for better understanding, let's change the values. Let's use A and B. I have stored value 1 in A, then in B I'll store 2. Now in capital A, I'll store a string which is apple, and then in B I won't create a B. So if I'll call small a, it will give me 1, the value stored here. And if I'll call B, it will give me 2. Likewise, if I'll call A, it will give me apple. But if I'll call capital A, will it give me something? No, it will throw me an error, which is name error. That name B is not defined. Did you mean small b? So, no. So that's how we justify that, okay, Python is case sensitive. So we will explore this in more detail when we study identifiers. So what does it mean that the variable name small a and capital A are not same, they are different. Moving forward, we have digits, the second category. So Python recognizes the digits from 0 to 9. Any number you write either from 0 to 9, any digit I mean, will be a valid character. So let's say I created a variable age 20, I'll pass. I'll create another variable, I'll give 0 here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Every of them is a valid character. So now what does it mean? That these are valid characters. But what if I type 0, 1? Here you can see a syntax error. Leading zeros in a decimal integer literals are not permitted. Use N0O prefix for octal integers. So octal is a data type, uh, is a is a way to express numbers. So in octal we have values from 0 to 7. In hexadecimal we have from 0 to 15, we assume, but it's A, B, C, D, E, then F. So it goes from 0 to F's. So that's how it works, and let's not get into it. For now, we just need to understand that yes, digits are also a standard character set which is being understood by Python. We also use white spaces. If I'll show you this name, so this white space character in between the name and the surname, the first name and the last name, is a valid character. It is being recognized by the Python. Now, white spaces, we have covered the third category. So in white spaces, we also have multiple ways, like space we have tab, we have new line. So all these comes in the white spaces category. You might think that space don't matter. In many programming languages, that's mostly true. But in Python, indentation is extremely important. If I need to justify a coding block, I need to use indentations. It justifies a coding block. So it will tell the interpreter, so see, from here to here is a specific programming block. It should be computed differently. So so you can see that if I will use this, if true, my bad, if true, print hello. Uh, yes, my screen is visible. I was making sure that it's getting presented or not. So yeah, print hello. If I'll do it, so what I'm doing right now that I'm using a conditional block if condition. That if it is true, it this condition should be evaluated. So now if I'll run this, else print not solo. So if I'll do this, there you can see hello gets printed. So how does Python know that it doesn't need to print this thing? It need to print only this thing. So for that, Python uses indentation. After this colon, this tab tells that okay, this is a this is a specific coding block. This whole is a single unit. This whole is a single unit. That's how it works. Moving forward, you can see in your right that we have covered letters, digits, then white spaces. Now it comes to let's come to special symbols. So the final category we can say is special symbol because these are the symbols that perform different operations or like have special meaning. So like some common symbols are addition symbol, subtraction symbol, or then asterisk symbol, then slash symbol, modulo symbol, equal to symbol, less than, greater than, parentheses, square brackets, curly braces, and many more. So each one of has their own specific purpose. For example, the plus sign perform addition. The plus sign also perform the concatenation. Then the equal sign assigns a value and parentheses are used while calling a function. So quotation marks are used to create strings. If we haven't used the hash symbol to write a comment. So comments are those blocks which are not evaluated by the Python interpreter. So like I can write anything here. So my name is Rishabh. I'm 20 years old. So if I write this, interpreter won't compute it. It will stay as it is. So we can write a comment using hash. We can also write a comment using triple quotation. So here is a multi-line comment. So basically it's a string, but you can use it in your programs to keep it as it is. Moving forward, so we get the plus sign for form addition, the equal sign assign values. In parentheses, we use for calling functions. Hash symbols for the comment, as I told you. Then colon is used after statement like if, as I demonstrated you right now. And in the previous lecture, I showed you how to use for loop. And functions also, we can define functions. So let's say if I want to create a function of for addition. So what will happen? A function add has been created. If I call it 1 comma 2, if I pass, it will return a value 3. So that's how it works. I'll explain to you how we create functions, how function actually works. So don't worry about it right now. For now, just focus on that Python character sets. So you will learn purpose of every symbol gradually throughout this course, and these there is absolutely no need to memorize them today. So now let's do something interesting. Instead of just reading about the character sets, let's open Python and write few simple statements. As we type, we will identify every character that Python is reading and understand how even a tiny symbol contributes to the program. This will make the concept much more clearer than simply memorizing a definition. So I'll open the idle shell again. So now what I'll be doing is I'll print a simple statement, an empty statement. So what is happening? Python is seeing print without any space, and it is calling the print function which is already defined. But what will happen if I'll write print with a white space in between? Will it work as it is? Let's see. See, here it is showing a syntax error, invalid syntax. So what actually happened here? Now print isn't pri, then a white space, then entry with parenthesis is not defined in Python already. So what is happening here? It is throwing a syntax error. It's unable to understand what is happening. But what will happen if I do print print instead of a white space, I write a underscore and then I write this. It will again throw a name error because pr underscore int isn't defined. So this is a valid, the thing before parenthesis is a valid variable name which you can use, which you can create, or the identifier we also say. So you can use, sorry. So the basically those curly brackets is to understand that, okay, to tell the compiler or the interpreter that we it needs to call a function which is named this, whatever is written before the parenthesis. So what the interpreter was doing, it was trying to call a function which was named, right? So let's define a function. To define a function, you need to do this. So okay, I'll use better variable name. So I have created a function named pr underscore int with multiple arguments possible. So this is a method. This is a way in which you can give multiple values within the function. So you can pass multiple values. So whenever I'll call print, I can write 1, 2, 3, 4, 5, 6, and if I'll run this, what will happen? Technically, it should print the numbers 1, 2, 3, 5, 6 with white space in between them. See, it is behaving the way the print function works. So right now it doesn't really make sense. We are creating a print function using the print function. So it was just for the demonstration purpose to make you understand how character sets works. Now we have spent enough time for the character sets. So let's move to the next topic, which is keywords. Not keywords, but before that, we need to understand what are tokens. Keywords are part of tokens. So Let me minimize the idle screen. So as you can see, what lexical unit of programming language? Most of you haven't heard there are tokens in Python. So now we have understand what a character set is. So let's move on a step further. Knowing individual character is useful, but writing a program isn't just about typing random letters or numbers or symbols. These characters come to form meaningful units, and these units are called tokens. So what exactly is a token? A token is the smallest meaningful unit of a Python program. Think of it like English language. English is made up of letters, and individual letters like A, B, or C don't usually convey much meaning on their own. But when you combine them, or you form word like cat, book, or computer, and those words have certain meaning. So programming works in a very similar way. Individual character combines to form a meaningful piece of code. So these pieces are called tokens, which are the building blocks. The smallest meaningful unit is considered to be a token. So let's understand this with an example. Uh, As you can see, my editing title screen, ideally screen. If I write age is equals to 20, then what does it mean? For the interpreter, for us it may look like a single line, but for the interpreter, it has three meaningful lines. The very first is age, which is a variable. The first token, we also call it as identifier. Then the second token here is an assignment operator. The third token here is a constant value, which is a literal. Here we are using a numeric type literal. We will cover all of these. So here you can see we have five type of tokens, keywords, identifier, little, and so on. So let me close my idle shell. Hmm. So what I showed you was age is equal to 20. Likewise, if I'll do print hello, again Python doesn't treat it as one word. It separates it into multiple tokens. The first token is print. So it will call the print built-in print function. The second token here is a parenthesis, the opening parenthesis. The third token here is hello, which is a string literal. The fourth token here is a closing parenthesis. So every token has a specific purpose, and together they form a valid Python statement. So now let's look at another example before we start. So let me open my shell again. Let's say if I define tax 30% and uh, I enter 1,000 rupees price. So if I want to print total, I'll create a variable total, then I'll write price plus price divided by 100 into tax. What will happen if I'll do this? It throwed an error. So here you can see I have written a wrong variable name. So PIC is not defined. So did you mean price? Yes. I wanted to type price here. That's a traceback. Here you can see that's a naming error. We can fix it. So if I'll run this, total will get a value 1,300, which is absolutely correct. 30% of 1,000 is 300, and 1,000 plus 300 is 1,300. Perfectly fine. So how does Python see it? Python reads it as here total is an identifier, then equal to it's an assignment operator. Then the price is another variable, an identifier, which is storing a numeric literal. Then here, then addition operator. Then here tax is also an not an operator but an identifier. So here in total we have 5 tokens. Have you noticed something interesting that Python doesn't care whether your program is 1 line or 1,000 line. It always reads your code token by token. So this is one of the first thing the Python interpreter does. Before executing your program, it start reading from the top to bottom token by token. So now you might be wondering what kind of token exists in Python. Here you can see on your screen that Python mainly has 5 types of token, which is keywords, then identifiers, then literals, then operators, then delimiters. So what are keywords? Keywords in short, we can say they are the reserved words that already have a predefined meaning, like if, for, while, and return. These are the keywords which I have shown to you till date. So there are many other keywords also. So and then about identifiers. Identifiers are basically the names created by programmers for variable, function, class, and other objects. So and moving forward, we have literals, the constant fixed values such as numbers, string, boolean values, and none also. Then operators, we have the symbols that perform certain operations which does something such as plus, minus, asterisk, division symbols, then modulo and equals to, and so on. Then we also have delimiters, or we say as separators. We also sometimes say that punctuators. So symbol that separate different parts of a program, such as parentheses, commas, colons, square brackets, or curly braces. These are delimiters or separators. So don't worry if these names sound unfamiliar right now. We are going to study each one individually in the upcoming slides with plenty of examples. For now, just remember this simple hierarchy. Characters combine to form tokens, then tokens combine to form statement, and statement combine to form a complete, fully fledged working Python program. So this hierarchy is very important because it helps you understand how Python reads and interprets your code. So now that you know what tokens are, let's start with the first one of the important types of token, that is keywords. So what are keywords? A keyword is a reserved word in Python that has pre-described meaning. In simple words, these are the words that Python already understand, which means that Python do know that it have a certain meaning. They are part of the language itself, so we cannot change their meaning or use them for our own purpose. So think of keyword as the vocabulary of the Python language. Just like in English, words such as if, while, or because have fixed meanings. Python also have words like if, for, while, class, and def that tell the interpreter exactly what operations to perform. For example, let's look at this code. I hope it's visible to you all. Yes. Let's say if I write if, I need to write a variable first. I need to create a variable named age. I already have age, never mind. We can confirm it also. So if I write if age is greater than equals to 18, print eligible to vote. It gives me eligible to vote. So what does it mean? Here the word if tells the Python to check whether a condition is true or false. We didn't teach Python what if means. It already knows because if is a keyword right now. Similarly, look at another example. Let's say for this, I'll use a for loop. So for I in range, for now we will just take 5 and we will print the iterations of range. So it will give me 0, 1, 2, 3, 4, every number in a new line. So here we go. So the keyword here we use is for. For tells Python to repeat a block of code multiple times. And let's say another example. Let's say we write the way I created the print function here, def pr underscore int. Likewise, we can create a greet function. There's no need to pass anything, I think. For now, I'll just keep it simple. It will be just printing hello for now. So whenever I'll call this, what it will do, it will print hello by default. So what does it mean? Here, the keyword def tells Python that we are defining a new function, which is named greet, and you need to call it whenever somebody uses greet with parentheses. And also, you notice something common in all these examples. The word if, for, and def already has special meaning, and they are in different color from everything other. So the words if, for, and def already have their special meaning. That's exactly why they are called reserved words. So can we create our own keywords? The answer is no. We can't do it. Keywords belong to Python. They are reserved by the language itself. So we are not allowed to use them as our variables name, functions name, or class name. It's not a good practice. So there is a data type called list. If you use list to create list, it's not a good practice to do. So if you will call list, it will give you an empty list. If you will do tuple, it will retain the it will give you the type of which type of object it is. You can get the same result by doing this type. Then one comma. So this is a tuple type data type. Here, another important thing which you should know. So, can we create our own keywords? As I answered, no, we can't. The keywords belong to Python. They are reserved by the language, so we are not allowed to use them as variable names, function names, or our classes names. For example, I demonstrated to you that I have a variable name, a list. Uh, so I should not use it as a variable name, or because it's not a good coding practice. But let's say I have class and I write class 12, it will throw an syntax error. So there are certain keywords which allows you to pass values, but the variables or the keywords which have certain structure, they will surely throw an error whenever it doesn't fit the structure it needs. Because Python sees the keywords differently, so that's why it behaves different for the list and for the class. The list is not a keyword, or maybe it is. So here on the screen false true. Okay, so it's not a keyword. That's why we are able to do it. So that's how we learn everything new every day. So again, so as I use class is equals to 12, this produces a syntax error because class is another reserved keyword. This is one of the most common mistakes beginner makes. So they accidentally try to use keywords as variables, and the names they whenever try to want. So it's not a good thing to do. So whenever you see a syntax error after using word like f or y class or return as variables, means remember that these words are reserved and cannot be reused. So how many keywords does Python have? Python has around 35 to 36 keywords depending on the version you are using. As Python evolves, new keywords may be introduced or older ones may change. So that's why the exact number can vary slightly between versions. The good news is you don't need to memorize all of them today. As you keep learning Python, you will naturally start using the most common keywords every day. How can we see all the keywords in Python? Instead of like searching every single time on Google, Python provides a built-in module called keyword. You can import keyword module, and then um, you need to print the list, which is you can do it using KW list. So I'll demonstrate it to you. You can also see it in the screenshot itself. So here you can see on your right side that we have imported a library named keyword. Then what we did, we printed keyword.kwlist. So the output we received was a list. It's I'll demonstrate it to you. Okay, it's I imported keywords. Then I keyword dot kwlist. So see, here I deliberately did the naming error, and you can see the interpreter showed that okay, you did a there's an error. It throws the name error. It tells that name keyword is not defined. Did you mean keyword? So yes, here you can see if I call this keyword.kwlist, it will give me all the keywords which are being used in Python or which are present in Python, the version which I'm using. So right now I'm using 3.13.5. So here you can see there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. Total 35 of keywords. So for the version 3.13.5, uh, the number of keywords available are 35. I have categorized these keywords in multiple categories, into different categories. I'll show it to you. So the very first, conditional keywords, then loop keywords, boolean keywords, logical keywords, function keywords, then except keywords, import keywords, class keywords, variable keywords, context keywords, async keywords, and then what are identifiers. I'll cover identifiers in the upcoming lectures, so don't worry about it. For now, let's focus on keywords now. The very first thing, the conditional keywords. Here you can see there are three keywords which I have put in front of screen, which is if, elif, then else. So here you can see the use of if is it executes code if a condition is true. Example use case you can see on your right. So marks is equals to 75. If marks greater than 90, print grade A. Else if marks greater than equal to 60, print grade B. Else print grade C. So that's one simple code. You can also understand the syntax. So I have what is happening here exactly, that we have created a variable named marks. We have assigned a numeric literal to it, which is 75. Now we have created an if elif else block. The if block is the if condition. We are asking if the marks is greater than equal to 90, it should print that grade as A. Else it should do marks greater than 60, it should print B. If none of these are true, it should print grade as C. So now the question is, what grade will be printed if marks is equals to 95? By now, you might have understood the behavior. So if marks is 95, the if condition will be true, then what will be happening to the program? If condition will get evaluated, it will be true. So print grade A will be printed, and the coding block won't move forward. For now, for this very specific example, which is 75, how marks is greater than 75, but it's not more than 90. So it will print grade B. Likewise, for any value less than 60, it will print grade C. Now, let's focus on these keywords, which is if, elif, and else. So these are conditional keywords. You will use it whenever you want to make a decision based on conditions. So the syntax is if condition colon, then the coding block of that section. If you have multiple if condition, you need to use elif after a single if. Then you can use multiple elif. So you can also nest them. That is, you can if marks greater than 90, if marks is equals to 100, print outstanding, else print grade A. We can do that too. We can nest the coding blocks. Moving forward, we have loop keywords. So here you can see for, while, break, continue, and pass. So loop keywords help you execute a block of code repeatedly. Whenever you want that, okay, I want this task to be done many times. So you don't need to write that thing. Let's say I want to print the table of 10 up to the value 20. So 10 ones are 10, 10 twos are 20, 10 threes are 30, 10 fours are 40. So if I want to do this, I can use a for loop, I can use a while loop, so that it will make things better for me, easy for me. The syntax to use for loop is for an iteration, then print I. So here what I'm doing, so I have we have an iteration, we have created an iteration using the variable I, which will iterate over range 5. Range 5 will give us values from 0 to 5, 0 to 4, not till 5. So the for loop will print I, and the value of I will keep incrementing again and again as the range, as it moves forward every single time. Likewise, in the second code block, which is here, we have declared a index is equals to 0, while index is less than 5, while condition, then semicolon, then the coding block which needs to be repeated. So print index, we will be printing index, then we will incrementing that same index. So what will happen here? Index is equals to 0, the value is stored right now. It will, the condition, it's true, 0 is less than 5, it's true. So while true, it will move forward, it will print, execute the coding block, which is print index. The current value for index is 0. It will increment the index. So index plus is equals to 1. It incremented index with the value 1. So the current value of index is 1. 1 is less than 5. Okay, true. So while true, print index. Now the value of index is 1. So 0 got printed, 1 got printed. It will keep on repeating till the value is 5. Now value is 5. 5 is less than 5. No, it's not. So it won't, the while condition will become false and it will move forward. So we use for whenever we want to repeat it over a sequence, and we use while whenever we want to repeat it over a condition. So we also have three other keywords, which is break, continue, and pass. We use these to manipulate the loop. So we use break to stop the loop. It, whenever the break is called, the iteration, the current iteration of whichever loop is being used, is being done, will be closed immediately. It will be terminated on the single call. When we will be using continue, what will happen? The condition where you have written continue, that condition will be skipped. So it is also used. So like, let's say I have this iteration from 1 to 10, but I don't like number 6. I want to skip it. I don't like number 3. I want to skip it. So what I'll do, I'll use if, I'll create a for loop from 1 to 10. Then I'll write an if block. If I is equals to, if I is equals to 3, or if I is equals to 6, you need to continue it. So it will skip that iteration. It will, but it will keep on moving the iteration forward. It won't stop the iteration. Now pass, it's a placeholder. It does nothing. It literally does nothing. It is a placeholder. So while, like, you know that you need to put it, you need to put something after, you have written a if condition block, then you want to write something in else. So while you have completed your if thing, you haven't finished your else condition, you can write pass, so that the syntax is correct. So for now, how many times will the loop execute? as I told you, for I in range, what range does it create objects 0, 1, 2, 3, 4, and the for loop iterates over it. It iterates over 0, 1, 2, 3, 4, one by one, and keeps on printing. Similarly, for while, as I explained, it started from 0, then moved 1, 2, 3, and 4. When it was 5, it stopped. So 5 times, 5 plus 5 in total, these loops were executed 10 times. The output will be 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, all in new line. Moving forward to the next slide, which is Boolean keywords. So Boolean keywords are they represent the truth values and the absence of a value. Absence of a value is represented by the keyword none. So whenever there is no value assigned, you can use none. So let's say you want to reserve a variable age. So what you can do, you can to avoid to avoid the name error, what you can do, you can create a variable age, you can pass the value none in it, so it won't have any value, there is no value, but the variable is created. Likewise, we have two other keywords, which is true and false. So true represents the truth, so the it logically means, okay, this is true, the condition is true, it can work. And the false, it represents the falsehood. Here example we have used is logged in is equals to true. If is logged in, it should print welcome, else it should print no login. So right now is logged in is true here. So if true, okay, the if condition sees that this condition is true, the if condition the if block will operate. So in here the value the instruction is it should print welcome. So the output on the screen will be welcome. Now, as we have asked, what will be print if is login is equals to false. If it is false, it will move forward. There is no else if block. So what it will do, it will again move to the else block because there is nothing true. So the else block will get executed. So the instruction here it is to output no login to or to print no login. So this is Boolean keyword. Then logical keywords and or and not. So logically keywords combine or reverse conditions. So like here and both condition must be true. For or at least one condition must be true, and for not it reverse the conditions. Here the example use case you can see age is equals to 20 and citizen is equals to true. If age is greater than 18 and citizen, that is if the person is the citizen, it should print eligible, else it's doing nothing. So what will happen if citizen is false? Before that, I need to explain you the truth table of and or and not. So now as you can see on your screen, I'll zoom it in. So these are the operators: and operator, or operator, not operator. These are the keywords which are being used to express logics. So if both the values, so and or and not, they are operators, so they need some operands. So and or need two operands to operate over, and not it needs only one operand to operate over. So that's why here you can see for and we take two inputs, for or also we take two inputs, but for not we only take single input. For and, if both the condition is false, it will result in a false output. Likewise, it will be false if either of the condition is false. If either of the condition is false, and will give you a false output. But if both of the condition are true, and will give you a true output. Likewise, for or, if either of the condition is true, it will give you true. So it means here you can see This is true here. This is true here. Both are true. So it will give you true for all these values. But here none of these are true. So it will give you false. What not does, it just reverses the value. If it's false, it will make it true. If it's true, it will make it false. As simple as that. You need to memorize it because we will be using it for multiple programs. Because conditions, we do create conditions. So make sure you mug up these values. Moving forward to the next keyword. So here you can see we have three keywords: def, return, and lambda. So the function keywords are those which define reusable blocks of code and returns a result. By syntax, here you can see we have used def, then there is a function named square. In parentheses, we are taking there's a parameter x, so it is returning x asterisk x, which is x square basically. So if you will call this function, it will return square of x. So another thing is lambda. So lambda creates an anonymous function. This keyword is used whenever you want to create a single line function, an anonymous function. You don't want to write a complete code of block. You just want to write a simple single line code which makes a function. So for that you can use the keyword lambda. We also I have also written the syntax for it. So you need to take the variable which whatever variable you want to take for the function name, of course. So that variable, then you have to use assignment operator. After that you have to type the lambda keyword. Then you need to take the operator, the arguments which you need to take. So for now, I am creating a cube function. So what I did, I took a variable x. Then after colon, the value which you are writing is the thing which will be returned. So here, what is happening? A function named cube is being created, which is returning x cube. As I have already taught you that double asterisk is nothing but exponential operator. So x exponential 3 is x cube. So it is returning the cube of x. Now the question here is, what will square 5 return and cube 2 will return? So as I told you, for cube 2, it is returning cube values. So 2 into 2 into 2, which is 8. For cube, for square 5, it will return 25, 5 into 5. As I have explained you anonymous function, let's understand the complete function. So which is with how we use def keyword to create a function. If like in other programming languages like C, you need to define what data type the function will return, but in Python you don't need to do it. The Python does the work on its own. If you don't want to return anything, you can do that as well. So it will be a void function. It won't return anything. It will just do the computation part. And return, the return keyword, whenever you write the return keyword within a function, it returns a value. For example, if you have studied list before, or if you're using this code like this course for your revision purpose, you might remember that in list there is a function called pop. So whenever you do it, it returns a value. I will demonstrate it to you. So there is a keyword, not a keyword. So I'll create list. Okay, my watch. So this here you can see it's a type error. List object is not callable. So I have created a list. When I'll call it, you can see the values present here. But if I'll do list.pop, I'm calling a method which is pop over list object. So if I'll do it, it is returning a value 3. So what it does, it removes the last very element from the list. If I'll call the list again, you can see the last element is being removed. So this behavior can be achieved using the return keyword whenever you want to return something in your program. So that's how it works. And regarding the lambda function, let's say I want to create add 1, 2. I need to check whether I have created. Here you can see I haven't created an add function yet. So if I have to do add, then I have to do lambda and I do x comma y, then I return x plus y. Now if I do x, if I do add 1, 2, I just copy paste this thing, you can see the output is 3. It is returning a value 3. It is equivalent to def add x comma y return x plus y. This is equivalent to that only. See, so these are the methods. You can create functions for repeated use. Don't worry about it. We are just having a look over the keywords. I'll tell you how to make better keywords. How to first very thing we will be covering is how to create identifiers, the valid identifiers which Python allows. Then we have except keywords, which is used whenever you want to do exception handling. So you can see these errors. To avoid this, we use try and except, try pass, then except pass. So that's how we do. So this is a syntax. There is a try block, then there is a except block. So these are the keywords just which comes under the category of exception handling. Try, except, finally, and raise. So finally is also a category which always get executed. So let me, it always get executed. See, so that's how it works. So we use it for exception handling. If you think this lecture isn't enough to understand keywords, I'll also revise it in the upcoming lectures. Then we have import keywords. It is used to import libraries. You can use from as for aliasing, and we use from whenever you want to only import a specific portion. For example, I have imported math library, then I am printing square root of 25, which will give the value 5. And as I told you, you can use as keyword to do aliasing, which is, let's say I don't want to type math dot square root. It seems big to me. I will just import math as m. I'll demonstrate it to you. See, you can do import math. I did. Then I print m dot square root 25. It will throw an error. But what will happen if I do import math as m? Then I try to do this. See, the output I'm getting is 5 without any error. So this is aliasing using the as keyword. And if I only want to import square root, that also I can do. At from math import square root. Then we have class keywords. This will be used when we will be studying object oriented programming. So here is an interesting question for you. So what is self used for? Why I'm using self here? You need to find the answer. If you get to know about it, well and good. If you are unable to find the answer, don't worry. We will be covering it in the upcoming lecture of object-oriented programming, where I'll tell you that, okay, there's an object, there is a class, there is an object. To refer to an instance of the object, we use self. So you might not understand it right now, but don't worry, you will be able to understand it in future. Now we have variable keywords. We have certain scopes, global scope and local scope. So for manipulation of the scope of variable, we need to use these keywords. Then we have context keywords with as. So we also use it. We will be using it for managing blocks. And as I already told you, one use is we use as for aliasing, and another is to assign a resource. So here I have aliased it only, that I have assigned a resource which is this file.txt to a variable f. That's one use. Then we have async keywords, which is used for asynchronous programming. And here we have two keywords, async and await. So in next lecture, we will cover what are identifiers. So for now, you can uh, uh, get an idea that in programming languages, identifiers are names used to identify a variable, function, or other entities in a program. We will learn that how we can create a correct, understandable identifier with good coding practices. So that's it for today's lecture. We will be covering more in the upcoming lecture. That's it for today. Have a great day ahead.